In this video, we're going to do another example of summation notation and also see if we can reverse engineer our summation notation. So here we're taking the sum from I equals 0 to 4 of 7 plus 2i. Now we notice here that our letter was I instead of n. That's totally fine. Our index can probably be anything. It's usually going to be I, N, or J sometimes, maybe K. Those are the letters we tend to use, but it could be something else. So we're just going to follow that same pattern. I'm going to start by plugging in 0 for I, and then I'll plug in 1 for I, and then I'll plug in 2 for I, 2 for I, and then I'll plug in 3 for I, and then I'll plug in 4 for I, but wait, that's where I need to stop, because that was my top number here. So if I look at this, I'm going to have 9 plus, oh, nope, not 9, silly me. I'm going to have 7 plus 2 times 0, that's 7, plus 9, plus 11, plus 13, plus 15. If we add those all up, that is a 4, not a 9. And if you add up all those numbers, you should get something like 16, 27, 40, 55. That's our number. But I want to look more carefully at this sequence of numbers that we have there. A sequence is just a list of numbers. So let's look at this. What I notice is this starts at 7. It goes up by 2. That has 5 numbers. Let's see where we can find those things in our summation notation. Well, this starting at 7 kind of represents this constant term that we had in our expression that we were summing. Going up by 2, that was the constant or the coefficient in front of I. And it had 5 numbers. Well, 5 didn't show up, but we did sum the numbers from 0 to 4. This is 1 less than 5, or 1 less than the number of terms. And the reason it's 1 less than the number of terms is because we started at 0. Since we summed from 0 to 4, then the numbers that we plugged in were 0, 1, 2, 3, and 4. That's a total of 5 numbers. So what I see is that if I want a sequence that starts at A, goes up by B, and has C numbers, or we'll say N numbers. One way to do that is to have the summation from I equals 0 to n minus 1 of A plus BI. Now, that's not the only way. Another way that you could do this, and I encourage you to check it out, is to have it go from I equals 1 to n. But then we have to be a little careful with our starting number, because if the first thing that I'm plugging in is 1, then this constant up here needs to actually be A minus B to kind of counteract the fact that the first thing I'll be plugging in is 1. So I'll have A minus B plus B. That ends up being my starting term of A, which I wanted. Or an even better way to write that, which we'll do here, is to just do B times I minus 1. Those will get you the same thing. I think this one's a little nicer to work with, but you know, your mileage may vary. So let's look at this problem here. We have the sequence -4, -1, 2, 5, 8, 11. We're adding all those up. How could I write those in summation notation? Well, let's see. One way I can do that is I can have the sum from I equals 0 to, I have 6 terms here, so I'd want to go from I equals 0 to 5. And then I'd want to have my starting value, -4, plus, what does this go up by? It's going up by 3, so I'd want it to go up by 3i. And let's just double check. Does this do the job? Does this do what I wanted it to? Well, let's look. First, I'd plug in 0. That's going to be -4. Then I'd plug in 1. That's going to be -4 plus 3. That's going to be -1. Then I'd plug in 2. That's going to be -4 plus 6. That's 2. Then I'd plug in 3. That's -4 plus 9. That's 5. Then I'd plug in 4. That's -4 plus 12. That's 8. Then I'd plug in 5. That's -4 plus 15. That's 11. And hey, I plugged in 5. That means I need to stop. And we see that I get exactly the sequence, or exactly the sum that we wanted. So there you go. That's how you can write a summation using summation notation.